Okay, so today we're going to talk a little bit about Module 2, Lesson 5, and this is going to be an extension on the linear equation solving that we've been working on throughout this module, but we're going to kind of take it to the next level and look at some applications of this and how we can use it to solve some problems. And there'll be a couple of different styles of problems. The first few are just translations where we're going to get an English sentence, we're going to translate it into math, and then we're just going to solve that equation. So if we look at a couple of examples of that, it might be something like the sum of 4, 7, and a number is 18, and then we're asked to find the number. Okay, so for a question like this, we just want to translate it on over. So the word sum means we're going to add these three things. So we're going to start there, 4 and 7, and our number, which I'm just going to call x. Anytime we see the word is in a problem like this, that's where we're going to put our equal sign, and then we'll bring our 18 on down. And once we've got it translated over, what we're really looking at here is just a linear equation to solve, just like we have in the last couple of lessons. So we want to start by cleaning it up as much as we can. A couple of like terms over here we can put together. So we start there, and then we collect our like terms next. In this case, I just have this one x term here, so I don't want to mess with that. I want to get all my constants and move them over to the other side. 11 minus 11 will be 0, so those will cancel out. And then 18 minus 11 gives me 7, and we're done because the x is by itself. Remember, that's our goal whenever we're solving these equations, is to get the x by itself. So when we get to that point, we're done. So for these first few questions, it's just a matter of translating it over to make an equation and then solving to see what's left. Now, the second part of this lesson, definitely a little more involved. We're going to look at some actual application problems. I'll go ahead and throw one up here. So this one says a bird species can travel 6 times as fast as a bird species of bee. If the total speeds for these two birds is 245 miles an hour, we want to find the fastest speed for the bird of species A and the fastest speed for the bird of species B. So whenever you have a problem like this, I know word problems are challenging for a lot of students, and I think one of the reasons is because maybe we don't take the time to set them up to give ourselves a good chance to get organized. So that's going to be what I'm going to do first. I've got two different things I don't know. I've got the speed of bird A. I'm just going to call that A. Okay, and then I've got the speed of bird B. And I know people really hate taking the time to write out a step like this, but to me it's valuable for a couple of reasons. The first one is it gives me somewhere to start from to help myself get organized, and then also at the end, when I get an answer, I can figure out what that answer actually means very easily by just referring back to this step. So I would definitely always recommend taking, how long did that take? 10, 15 seconds or something to write down, we call this defining the variables. Certainly worth taking a second to do that to get yourself organized, okay? So then I'm going to kind of use this to try to set up an equation. So it says here, a bird of species A can travel 6 times as fast as a bird of species B. Okay, so I don't know anything really about species B speed, but I know that the species A speed can be 6 times as fast as the speed of species B. So we can also call this 6B here. Okay, and this is important because for us right now, we are dealing with equations that have one variable. We want both of our expressions here to have the same variable in them. So now I've got them both in terms of B, and that's good. We also know that the total speed for these two birds is 245 miles per hour. Well, that total right there is another key word that we're going to need. Total means we're going to add it up. It's just like when you go to the store and you get a receipt, right? That total at the bottom of the receipt is just the sum of all of the prices of the things that you bought, right? So what we're going to do next is we're going to take these two expressions and we're going to total them up, which means we're going to add them, and then it tells us here that that is 245 miles per hour, and we've got our equation now. Okay, and now actually solving this equation, it's not too bad. We just going to work it out, and like terms here, so b and 6b, we can add those together just using all the same strategies that we did before. Our second step is to isolate our collect our like terms is what we called that. So we wanted to get all our b's on one side, all our constants on the other side. That's done for us. My b's are on the left, constants are on the right. Don't need to mess with that anymore, right? And so to finish up here, we're just going to multiply or divide. In this case, we need to divide to get rid of the multiplication. Remember, whatever we have, we're going to use that opposite operation. Cancel those out. Divide this out. And we've got our b value. Okay, now what did I find? Well, I found b, which is the speed of bird A. So I'm sorry, for bird B. Okay, and then to get the speed of bird A, which I also need, right? It asks me for both the speed of bird B. This is 35. Right? I also need to find the speed of bird A. Well, there's a couple of ways I can do that. I'm going to come up here first, I think, and just plug right into this. So 6 times b, right? Just work that out. Okay? And that'll give me my speed for bird A. Now the other choice is, I know the total speed for these is 245. So I could do 245 minus 35. And that'll get me there as well. So there are a couple of choices for how to get to there, but we'll get the same answer either way. Okay, and this is why I think it's important to take a second at the start of these kinds of problems to get things set up, get things organized, because it gives us somewhere to come back to at the end of the problem and really figure out what our answers mean. This is a skill that we don't spend enough time on in a lot of math classes. If you want to use math in the real world, then you got to be able to take a real world problem, translate it into math, do the math, figure out what your answer means, and then translate it back into English. So figuring out what your answer means is an important part of doing math in the real world. And so we're definitely going to be focusing on that as we go through our math courses here. Okay, so let's do one more word problem. One down below here. So it says, organized here, sorry about that. It says, by ear, the distance from city A to city B is 3,007 miles less than the distance from city A to city D. The total of these two distances is 7,803. Find the distance from city C to city D. Okay, so again, I'm going to take a second at the beginning. There's like a lot going on here, a lot of words, a lot of things to think about. So to me, you're really going to put yourself in a little bit of struggle if you don't take a second to get organized. So got the distance from city A to city B, so I'm going to start there. Okay, and I've got my city C to city D distance. Okay, so when I read this, what I like to look for first is what do I know the least amount about, because that's what I'm going to make my variable. So I know the distance from city A to city B is 3,007 miles less than the distance from city C to city D. So I know a little bit about city A to city B, right? I know this fact right here. Doesn't tell me much about. I can maybe back into it, but it just doesn't give me much to work with. So when I have that situation, that's going to be my variable. And what variable do you use? It doesn't really matter. I'm just going to use x here, but you can use whatever variable letter you want. Okay? And then the distance from city A to city B is 3,007 miles less than x. I've just called this x, right? And this is one we have to remember that less than phrasing is one of the trickier terms that you can run into sometimes. We need to kind of reverse the order. So 3,007 miles less than x is going to be actually x minus 3,007 when we write that out. We have to reverse the order because of that less than phrasing that we see in there. Okay, and then the second sentence here tells us that the total of these two distances is 7803. So we take these two expressions and we total them together. Okay, now this is a very important thing to think about. We saw this in the last problem too. I maybe should have highlighted it more there. But we have two things we don't know here. We have the city A to city B distance. We have the city C to city D distance. When we have a situation like this, where we have two unknown values, when I'm putting my equation together, I better have two x's in my setup. It's super common to just say, oh yeah, x minus 3007 equals 7803. That is no good to us because we don't have both of our unknowns in the setup there. So for almost all of these word problems in this section, at least the more complicated ones, like the last couple that we've done, we are going to have two unknowns in our setup initially, right? And then we'll simplify it and we'll work from there to get less. But it is important that you have both of your variables in here. If you don't have two variables, you probably messed up the setup, okay? And then we know that the total of these two distances is going to be 7803, so we can bring that on down. And then this is our equation, and now we're just going through our process like we did in the last couple of lessons. We're going to start by cleaning it up. Got a couple like terms here to put together. Okay, and then we want to start solving for x, and our next step is to combine our like terms. So we'll move this, collect our like terms on opposite sides, move that on over. Okay, leaves us with the 2x. Okay, then we'll divide as our last step here to finish up. Oops, sorry. What is that? 5405. Okay, and so what did I find? Again, this is where it's really nice to have this setup to come back to. I found x. Well, x is the distance from city C to city D. So this is 5405 miles per hour from city C to city D. Okay, and then if I want to get the other one, I have a couple of choices. I can just take this. Most of the common way to do it is just to take this, plug it back into our other expression here, right? So 5405 minus 3007. Okay, and that'll give us, whoops, should be 5405 there. Okay, the other choice is just to take our total distance, 7803, and subtract the 5405 from that. Either one of those will work and give us the right answer. What is this? 2398, I think. Whoops, sorry, not miles per hour. Those are just miles. Okay, and again, it's very important. Because we're doing so much in my math lab, you'll have some questions on this. Won't maybe stress it as much as I do, but it's really important when you're doing these kinds of problems that not only are you able to do the math, but you're able to tell someone what the math's answer means. You've got to be able to interpret your results, because if you can't, there's no point to doing any of this stuff. We use math to solve problems in the real world. If you don't know what your answer means, there's no reason to do it, right? So hopefully that's enough to get us off to a good start on these. Please don't hesitate to let me know if you have any other questions at all.